these are the solutions to the energy problems from the energy lecture from chapter 5 and 6. So we're going to start first with the gravitational potential energy problems. So the first one, what is the potential energy of a 2.14 kilogram book that's on a bookshelf 1 meter above the floor? So we are going to use the gravitational potential energy equation because we can tell that that's what we need. We've got a book that is above the floor, so that tells us gravity, and we've got mass and we've got the height. So we just plug in the numbers. So gravitational potential energy equals the 2.14 kilograms times gravity, again 9.8 meters per second, and then times the height, 1 meter. And when you plug in those numbers, if you multiply them together, you get 20.9, and the unit for energy is joules. So 20.9 joules for the first problem. The second problem is a little more difficult because you have to rearrange the equation. So what I do is I actually just go ahead and set it up in the same way and then move the numbers around as I need to solve. So here, a box has a mass of 5.8 kilograms. The box is lifted onto a shelf, so we know we're working with gravity again because we're lifting. If the box gains 145 joules of potential energy, how high is the shelf? So again, we've got a gravitational potential energy equation, and we just plug in what we know. So we know we have the mass, so we have m. We have gravity, so we know that one. And it told us the potential energy. So we just plug those numbers in. So we've got our potential energy, the mass, and gravity. We leave the height out of it. So we need to solve for the height. So these numbers have to move to the other side. Since we're multiplying over here, that means when we move them, we're going to divide this side by these numbers. So just move them over, 145 joules divided by 5.8 kilograms times 9.8 meters per second equals the height. So if you do that, so if you multiply the 5.8 times 9.8 and then divide 145 by that, you get a height of 2.5, and I left out the units there. I was trying to be really good about making sure they're all typed in. But you get units of 2.5 meters, and you know it's meters because we have the meters per second for gravity, plus all of the other units in here are in metric. All right, so for the kinetic energy, so you've got a, the first one is a 3.5 kilogram bowling ball moving down a lane with a velocity of 5.0 meters per second. What is the kinetic energy of the ball? So we know we need to use our kinetic energy formula. So that's the 1/2 times the mass times the velocity squared, or the speed squared. So we've got the mass, we have the velocity, so we can plug those in. So 1/2 times 3.5 times 5. And so, like I said, first thing I always do is go ahead and do the square if I just have like a regular calculator on me. So 1/2 times 3.5 times 25. If you plug that in the calculator, that will give you 43.75 joules. So that gets us the 43.75 for the first one. So I'm going to record that up here next to this one so we have it to compare the other ones to when we're done. All right. And, oh, I'll put it back later, I guess. So 43.75 was the first one. Our second problem is 7.0 kilogram bowling ball now moving down the lane with the same velocity, 5.0. What's the kinetic energy of the ball? It's the same setup. So we're going to use the same formula. We're going to just plug in the 7 kilograms instead of the 3.5 kilograms. And so when we do the math for this one, we get 87.5 for the kinetic energy. So that makes sense. It's double, and the mass of the ball was twice as much. So if you think about it, things that are bigger are going to have more energy, are going to do more damage when you throw them or, move them around. So let's take a look at the last one. So the last one is, what would the kinetic energy be if the 7 kilogram ball was now traveling at 10 meters per second? So now changing that velocity. Again, same equation. So now we've got 1/2 times 7 kilograms times 10 meters per second squared. So instead, we've got 1/2 times 7 times 100. And when you multiply that out, that gets you 350 joules. So let's take a look and compare these guys now. So we had 43.75. And then you had 87.5, and now 350. So you can see that the velocity, the speed, has a much bigger effect on the kinetic energy than the mass does, because here we doubled the mass and it only doubled the kinetic energy. Here we doubled the velocity and it more than well doubled the kinetic energy of the object. All right, that's the end of this